Morning or good afternoon.
Good morning. Yeah, but a very good morning to you, and thank you for having us in the early morning. And let me have a very brief wrap up about your person and what you'll be talking about.
Okay.
You're the principal with BOULDER Associates, architects with a rich experience in delivering projects for several Fortune 500 clients. You are specialized in last planner system and target value delivery and integrated project delivery with a focus on design and pre-construction. You're in the board of directors of the Lean Construction Institute. So our mother that more or less influenced us very much when we started off with the GLCI in Germany. And you are talking today and will be talking about next generation target value delivery. And I don't want to dive into anything that has been written about that, because definitely we should listen to you, but I'm very, very looking forward to what's the next generation is, because target value delivery is something we all heard about, we maybe have had some contact with, but obviously there is something that has been derived from that, and there is a next step to go. So looking forward to that, and the floor is yours.
Thank you. I'm not able to share my screen for some reason here. It says that it's disabled.
Let me see whether the technique can help us.
Okay. Thank you. Now I can. Thank you.
Okay.
Are you able to see the screen?
I still see your picture, Romano.
Okay. Are you able to see the screen now?
No, sorry. I tried to get some support. Hallo Thomas, bei Romano Nickerson geht. Romano, the presentation is here.
You have it? Okay, wonderful.
Thank you.
Well, thank you for having me. I'm very honored to be part of this, and it was wonderful to listen to Joe and Keon, and they talk about Last Planner and about applying this type of thinking in the field. And so what I will do is to talk about what we can do in design as part of that overall effort. Just to give a brief introduction about myself. I work for Boulder Associates, an architecture firm in the United States. And within Boulder Associates, I lead a group called BA Science, which is a consultancy that focuses on lean solutions in design and construction. We work all over the United States, as well as in a number of countries around the world. As Klaus had mentioned, I am a principal with Boulder Associates, and I am someone who's been around lean construction for, gosh, 16 or 17 years now. So this is very much a passion for me. So what I am planning to talk about today is target value delivery, which is a notion about the way that we can better deliver projects, primarily through the involvement of trade partners and bringing not only cost, but also the means and methods of construction into the design phase. Architects are trained to take on all kinds of input from various sources, from the owner, from authorities having jurisdiction, from model codes, and also from the environment around the project itself, et cetera. And so they're used to trying to synthesize these different ideas and bringing forward ideas from construction through target value delivery is something that architects should be able to do, and to be able to have that type of input be part of their design. I've been fortunate to work on a number of different projects using target value delivery. A couple examples here from Disney. I've done this on a number of hospitals, medical office buildings, and then the picture in the lower right is a project for Google, their headquarters in California that I was part of. And this is something that I have unfortunately seen that people have taken to interpreting target value delivery in a very simplistic way. Usually it is simply the idea of adding a pricing exercise to the design phase. And I will show you today how that is only a very small part of a rich implementation of target value delivery. So with that, just to give a brief overview of target value delivery itself, this is a very much a working map of what target delivery looks like within a project flow. And by that, I mean that this is an example of how it may be put in place, but it is also something that would grow and evolve over time. The way to read this is that as a matrix from left to right, time flows from left to right, and then the swim lanes are listed on the left-hand side. The thing that I want to focus on today is that in my mind, there are two main divisions in terms of the way that target value delivery is implemented. And the first is when you are in the early conceptual or validation phase of a project. Those are the two columns on the left-hand side. And then the way that target value delivery would be implemented on a capital project. And that's the remainder of the squares here. And of course, we'll be more than willing to share this presentation for anyone in the audience so that you can look at this more closely. The thing with construction, design and construction, is that there are two different focuses within design and construction. The first being on systems and methods during design, and then a shift to really looking at labor and production during construction itself. So we'll get into all of that information as we go here. In terms of organizing the project, Typically, a target value delivery implementation relies on a big room, which comes from the Obeya room of Toyota. And the notion here is that the team is organized around larger divisions of the project. And in this case, the big room can be in person or it can be virtual, especially now during times of COVID. We find that we need to come up with ways of bringing people together in virtually so that we can keep as many folks safe as we possibly can. This is for a project that I'm currently coaching at the moment, and in that big room we have 3 major divisions organized around the building: the exterior, the building systems, which would be anything that's in the walls or in the plenum space, and then the interior fit out. And then off of that are cluster groups. The cluster group is organized around a particular scope of work and would include the stakeholders. So building systems may include mechanical, electrical, and plumbing and fire protection, as well as the architect and the builder, and then the owner as well. Every cluster group should have the owner and the builder and the architect as their baseline member, and then the subject matter experts that you heard Joe talk about earlier. And the same way for planning the work, this is where they would execute that work. Typically, we would rely on the on the builder to provide the scheduling and the pricing information as that expert, and then delving into the specific systems that are being designed. And as I mentioned in the design phase or the validation phase, the goal is to design the building. The architect and engineers focus on the design of the building itself, while the builders and trade partners focus on designing how to build the building. So they are in a design phase as well. Within that, typically the meetings of a cluster group would occur weekly, and their goal is to work through and find value in the design of the systems, and then the detailing of those systems, and then to use a number of methods that we'll get into to drive value into their scope of work, and to thereby reduce the cost of that work. You can balance typically around one large overall number for the current working estimate. There's the ability to move between different cluster groups, move dollars between cluster groups, so that if the structural system makes some savings and the mechanical system needs additional money, then that can flow as needed. So with that, let's talk a little bit about the validation phase. There are a number of clients that I've worked with that have used an early validation phase as a way to understand what the project should look like in terms of scope and the business case, and then the design and schedule and estimate that would support it. In fact, they will typically spend 1 to 1.5% of the total project cost, the projected cost, to fund a validation study at the beginning. And oftentimes they will do that validation work before they present an overall number back to their finance board. And it's in my opinion, the most sound way to look at a major project is to pull together a team that can study and ensure that the project can actually be delivered and made operational with the available funds. So let's take an example of a hospital. This is a generic story, but it is from a project that I designed in San Francisco, a hospital there. What we sought to do within the value definition phase of the project, as we were looking at the validation, was to first understand the business case. And within a hospital, as within many projects, there are specific drivers, and that comes from the income that can be expected, whether it's the types of cases that would be seen in an operating room, or the number of visits of people that would come to the emergency department. Those drivers are all important to understand because they drive the building. And if you see 1,700 people per year, you can see 1,700 people in one room in an emergency department. So it's very much a math equation to figure that out. So for us, we needed to understand what was of value. And in the case of this hospital, they were very interested in how they could acquire physician groups to come in and do surgery. And that gave us a certain number of cases, and that told us how many operating rooms that we needed to be able to build into the footprint. With that allowed us to then establish some specific conditions of satisfaction, things that we knew we needed to achieve with the design, and then we took those and made them visible to the team. So the way that the exercises would work, we had a $250 million budget. We had 4 different service lines. The ORs, the operating rooms, had to do with the surgical capacity. Interventional radiology, or IR, was the first that we was a new service line that they wanted to include. They wanted to expand and have a larger lab that would allow them to do testing in the region. And they wanted to be able to right size the patient rooms. So in the diagram on the right, we have those 4 different service lines reflected. Now, as we start the exercise, we were asked first to look at 4 ORs. We were building on a very tight urban site that had a limited footprint. And so we ended up driving the design into a high rise, so a 7-story structure. The owner asked us to look at providing 5 ORs. They felt like they could add additional physicians that would allow them to handle more surgeries and therefore drive more revenue. The thing that we found, though, was that the 5th OR broke our floor plate, and it made us move one of the other program elements to a different floor that they would have preferred to have on the surgery floor. And then also at this point, we couldn't handle the volume of air changes required in the operating rooms without adding an additional mechanical unit. And so we were then able to report back that, yes, we could fit a 5th OR, but it meant that the program would change and that we would have to add additional mechanical capacity. So in the end, the owner decided, let's not do this. In another scenario, we might have planned for 3 ORs. And in this case, we did have shell space or room on the floor to add a 4th OR. And in this case, the owner decided, well, I don't have the volume right now, but let's shell the space for that operating room. And in the future, we'll be able to add that capacity as we bring on more physicians. And so then they would finish furnishing that room out of their routine operating capital instead of relying on the project to provide that information. So those types of iterations are the basis of target value delivery in this early validation phase. And so what we would focus on is these iterative loops where we would start with a space program that had a certain number, in this case, the number of operating rooms. And then we would try different scenarios, because if we can, in the same building for the same overall budget, provide additional capacity, that is of value to the owner. So in this case, we would have come up with a program request. We would have tested the impact on both the floor plan and on the stack, meaning the impact on the vertical section of the building. And then we would have turned it to our build partners to provide pricing and schedule impact for that additional work. And then their information on the cost would have been plugged back into the owner pro forma. for them to evaluate that for this additional initial upfront cost of construction, we would get an additional operating room that provides this many more cases per year with this much more revenue, and that it would, even though it cost more upfront, it would shorten the length of the return on investment. So then they would say, well, yes, that works, or no, that doesn't work with our pro forma. And so through a validation process around drivers like the operating room or the number of beds or the number of rooms in the emergency department, the value to the owner is the ability to try these different scenarios and understand for the allowable capital that they have, what type of return on investment will they have and how long will it take to pay off the building. What's key for the project team to do during that time period is to really look at several different areas of within a particular service line. And the three of them are the code requirements, and then what is required to be operational, and then a last element that is what I would call a value add element. And so most operating rooms here in the United States are over 500 square feet, despite the fact that the code minimum is only 200 square feet and 270 square feet. And so within that, it's important to understand what are code required things, what are operational things, and to hold on to them. Because the next piece, and I mentioned this earlier, is that once you have these items established, you can trade between different service lines. And you have elements that can be traded, which could include in an operating room the capability to do telemedicine, or it might include special ensuite equipment for imaging, etc. But we must always keep the must elements. You must always meet code. You must always be able to be licensed and be made operational and not be able to trade those away. So what this might look like then is that once you move beyond the surgical service line and look at beds or the laboratory or interventional radiology, you can alter different elements. And maybe the beds don't need as much value add as the ORs do. And that larger arc of the ORs representing more money would be the place where that's the best value for the owner, because maybe the surgical service line generates more revenue than the interventional radiology service line would. And so while all these things might be moved around in terms of putting money where the best value is, it's important to keep those outer two bands of must elements that must be preserved. So this is, as I'd said, the very early phase of the project. From there, we would move into design and pre-construction. And as I had mentioned, the challenge that I see most frequently is that design teams have failed to leverage target value delivery because they have simply looked at at pricing design work instead of really getting deep into seeking value and looking to eliminate waste. And so when we talked earlier about the cluster groups, I often get a question of, well, how do we actually make it work? Because we're in the cluster groups, we're using pull planning to organize what we're doing, but it feels like we're not driving our target cost. And so there are eight different elements that I have identified that are key to driving value into that exercise. As we look at these, the first is to design for constructability, and to be able to answer the question, can we put this work in place within schedule and on or under budget? With that, we need what I would call advocate as a policy of frequent sharing of incomplete information. So often teams will fall into keeping to pricing off of packages instead of being able to do conceptual estimating based on specific elements or even around a particular material in a certain setting. And for teams to be able to do that, they need to be able to have that type of conceptual estimating and be able to provide that or put that feedback into the design iterations. Need to seek ways to design for production. Ultimately, if it looks great, that's one thing, but a craft worker has to be able to put the work in place. And so having that knowledge from the trades in the design phase of how they're going to actually produce the work is absolutely critical. And this is also an opportunity to hold up the skill and the knowledge of the trade partners. Architects spend a lot more time in the field than builders typically spend in the office, in the design phase. And so it takes a while sometimes to get the trade partners to feel comfortable offering up their knowledge and expertise. But typically, once they do, they have so much to share. And so it's important for a team to be able to enable those folks. The next one is to design for specific means and methods. And in this case, it's important for each specific trade to have a representative who will actually put the work in place. And this ties in with the notion of the last planner. The last planner means the last person who plans the work before putting it into place. Often that's a foreman, can be a frontline craft worker. And so having that information available to the design team to know how to frame metal studs around a column for a rated enclosure, to know exactly how they're going to do that can and usually does impact the way that the details are drawn. And so who better to draw the details or to explain how the details should be drawn than the person who will swing a hammer, run a screw gun, that puts the work in place in the field. What's important here too, to continue to reinforce the craft workers, is to make sure that they are able to explain how they best can work. They are typically forced to do things with the way conditions are in the field, the way that the design comes to them, but it's important to encourage them so that they can express their best way to work and that the team can then leverage that. And usually that means a good savings for the team. Next is to design for procurement. Oftentimes the first solution is the solution that a team will go with, and yet if the builder can help the designers to understand, hey, there are these different alternatives that may cost less money or they're more readily available, etc. The designers won't usually know that information as well as the builder that's going to put that work in place. It's important as well to have an understanding of escalation within the market. That certainly affects the commodity-based scopes of work involving steel or copper or concrete. It's also important to think about the availability of materials, equipment, and labor, and to have a strategy in design that accounts for that. Next would be to design for supply chain itself. That has to do as well with procurement, and this is another opportunity for the builders and for the trade partners, especially, to be able to talk about the specific components within their design, and then to understand how the materials and labor will flow to the site itself. I have examples going back almost 100 years now of just-in-time delivery, specifically with the Empire State Building construction in New York City. They didn't have room. They had a tiny site. They had no laydown space. And so even then, understanding how material and labor would flow and not having room to just sort of put everything on the site and then grab it when you need it. It's critical to leverage that even when there is room within both the schedule and the physical space. And so with that come all kinds of wonderful opportunities from manufacturing, looking at kitting, looking at prefabrication, offsite staging, and then to really only have on site what is needed. And to build, it takes time to build those supply chains and the trust, which is a great activity for the builders to be doing during the design phase, is to be sure that that type of thing can be reliable. The next would be to design for work sequencing. This is where Joe and Keon didn't mention the parade of trades, but the sequence that that workers and materials need to flow through a particular space as they work. And Keon had mentioned, you know, the flow from foundations to erection to dry in to air to finish. All of those are sequences where you have the opportunity to understand how large the work area should be, the number of crew that should be there, and the amount of work that's done in a particular time. So key to understand that, because those pieces of flow can have an impact on how the design is done. And sometimes the design can be the constraint to the flow of those elements within a space. And therefore, if the design is changed, then there's an opportunity to provide savings for the team. The next one is to design for emerging technology. We need to think about what will be available and what will be an improvement on the day that the facility opens, or at least on the day that the material is procured and installed, as opposed to when the project started. So one project I had, hospital project in San Francisco that we mentioned earlier, we assumed that we would be able to afford the LED lights that we wanted to use long before they were competitive with fluorescent or incandescent lighting. And since projects, hospital projects in California take so long to deliver, by the time we did get to procurement, the price drop had been significant, and we were able to provide a cost savings as well as by meeting the energy saving requirements for the project. So always important within every scope within the building to look for those types of opportunity. The next is to create an environment that allows for innovation. You have to teach the team how to question what they've done, and to not just be content with the first answer. It'd be wonderful if every time we looked at something, we could have 3 or 4 or 5 different scenarios to evaluate, instead of just going with the first one that checks the boxes. Is there a better way? And so we need to do that by creating this notion that iteration is a value add, that it is not repetition. And I would propose a definition that iteration is repetition where we add value as we go. And so within that also creates a requirement that a TVD process does need an amount of time to mature. It's not a quick thing, because it takes time to get to a detailed level of understanding within a design, and to try to improve that is not something that happens overnight. One example I can think of is that when I was on a project, the Disney project that we saw, the Star Wars Land project, we missed a huge opportunity because there was I don't remember how many cubic yards of concrete we had, but there was massive retaining walls, nearly 3 feet thick, around a large, basically a big hole in the ground. And we ended up not being able to save money because we didn't have enough time to optimize the design for that retaining wall. And so, as it turns out, it could have been only 18 inches thick, and it ended up being twice that thick because we didn't have the time to really get into the design of the reinforcing steel. And so that is actually part of the progression within design that gets missed a lot of times with target value delivery, is that you have savings that you can find at the systems level, whether you're using evaporative cooling, or whether you're using one large mechanical unit or small package units that are distributed. And oftentimes that's where a team gets stuck. They get to the system level and then they don't go deeper. Whereas with a good TVD implementation, you get to the level where you're looking at the individual footing and looking at how the anchor bolts interface with the reinforcing steel in that particular footing and finding ways to remove congestion, etc. So that's how innovation can be found, is within that that detailed look as the team moves into the more detailed portions of design around a system. And then ultimately the last one here is the design for cost. All of these previous 7 elements are items that that are expected to produce savings if they're leveraged. And so capturing that and then working that not just within each cluster group, but using the risk and opportunity method, which is basically listing all of the potential impacts to the current working estimate. That is the key way to be able to keep track of this. So with that, those are my thoughts on how target value design 2.0 could help teams to go farther with target value delivery. And with that, I thank you for your time and I welcome any questions.
Thank you, Romano. And may I just ask the first question straight off? You said adapt a policy of frequent sharing of incomplete information. Mm-hmm. There is a big level of trust in that. How do you adapt a culture like that in a team? Because those teams usually not necessarily know each other very well.
Yes. Well, there are a couple things that have to come together. The first is that it's very helpful to have a type of relational contract, whether it's the integrated form of agreement or some other that allows the teams to behave in that way, because people will be afraid of sharing information if it's not in a specific package. And so that fear of liability will drive a lot of resistance to that idea. Then the second is to work toward building trust on the team itself. And I have often will start early on in the project looking for an opportunity to share information in a way that is vulnerable, that normally you wouldn't see. And it might be around a particular layout or something. And so I remember one time I went to the architect that was working on that particular part of the project and said, hey, I would like to share this in the big room meeting. And I know it's not done yet, but I will support you in this. And so then in the room with the full team there, they felt like they could share, and I backed them up very strongly and said, hey, remember, this is incomplete, but it allows us to do these additional steps rather than waiting for 2 or 3 more weeks for this information to come out in a formal package. And then doing something like that early on in a project makes it okay for everyone else to start doing that. And then I find that as time goes by, people are more and more willing to be able to do that. So number one, having the contract structure that allows it, and then secondly, to support and model that type of behavior early on, and then support it downstream.
Thank you. The big room, which role plays this obey our big room in this culture or in the whole project delivery?
The difference in my mind has to do with the type and the level of work. Most projects historically have been run using an OAC, an owner architect contractor meeting, which is really a status meeting. You get updates, you wring your hands about the challenges that you have in front of you. Hopefully you get to celebrate successes from time to time, but you don't actually really do any work. It's a lot of discussion and people promising that they will go back and do a particular thing and then return the following week or 2 weeks later with a completed, hopefully a completed issue. Whereas the big room has that, but also has the working groups. And those working groups can be the cluster groups. They can be kind of one-off meetings where there's an issue, a hot topics thing is something that we call it here in the States. These are the things that are bothering people or that they're worried about that we need to fix. And then they do actual work. You break into, if you have an issue with coordination around a beam depth in an area of the floor plan, then you pull together the stakeholders in that room, the structural engineer, the architect, the mechanical engineer, the electrical, and then you go get in front of a whiteboard or a monitor that's using BIM 360 and Navisworks, and you figure out how to solve it right there, instead of having it go back and have someone call someone else and, you know, all this kind of phone tag behind the scenes. Instead, you're solving problems right there. And often big rooms, they can be virtual, they can be in person, as I said, but the value from being together, being co-located, even if it's only a day or two a week, is that you are there and able to solve problems. You can turn to your colleague and say, hey, could you come look at this? And ultimately, instead of fixing problems, you start to foresee them and you start to say, hey, I'm about to design this particular duct run. If you could raise that beam, I can run, you know, this particular size through. And so instead of clash detection, where you're fixing something that's already happened, you start to do clash avoidance, where you're thinking ahead and you are designing in a way that is thoughtful and respectful about the other systems. It's a much more integrated way to behave.
Like a common workshop?
Yeah.
A shop floor?
Absolutely. Absolutely.
Oh, thank you. Thank you for that. I asked at the beginning what the next generation target value delivery might be, and you gave us several steps, quite an insight. Is it right to say that continuous estimating is really the next step? Because as I know, and maybe some of us know, target value delivery, it's historically very much based on designing to one estimate at a milestone. And listening to your explanation, it's more continuously developing the project and the estimation and the cost knowledge.
I would say that estimating is a measurement of something else. And so, yes, you need continuous estimating, but what you measure are those 7 first elements that I mentioned, and that has to do with leveraging the skill and the knowledge of the trades and the general contractor to contribute to the design process. And the way that they that can organize their work is that they always need to be in the mental model of designing how to build the building itself. And so yes, continuous estimating, but what are they estimating? It has to come from those 7 elements that we described, in addition to cost.
Mm-hmm. Planning for constructability was one of the key elements you mentioned early on as well. Okay, yes. Thank you very much for this insight.
You're very welcome.
And may I ask you a last question?
Please.
What would you recommend, if there was one recommendation to the audience you would want to just speak out?
Well, I think that the thing to do is, if I could encourage everyone to be brave and to not be afraid to put themselves out there in the design phase, that that would transform the industry. And to be willing to be that person on the project, to speak up with the voice on behalf of the owner, and to be the person that's willing to put their work out there. That's what it will take. You know, just 1 or 2 times on a project can transform the entire delivery. And, you know, 1 or 2 projects start to transform the industry. So I would encourage everybody to be brave. It's amazing how people will respond, and it's a wonderful way to lead from within the team.
So thank you very much, Romano Nickerson, for sharing all these insights with us. And
you're very welcome.
Best.
Thank you.
Bye-bye. Thank you.
Thank you.